for another Green Builder Media webinar. Did you know that September is International Women's Friendship Month? Well, it is. And since I count Mary Kessner, our production manager, and today's guest among my friends, I am in full celebration mode. Now, before we get to who this friend is, let's cover what she's talking about. The topic of today's webinar is the 2021 International Energy Conservation Code, or short IECC. Specifically, she's going to focus on the compliance paths, key changes, and implementation of the residential section. And the best part might be that she's going to address where you, our industry professionals and homeowner friends, should focus for maximum energy cost savings. Now, here to share all that awesome knowledge with us is Shaunna Mozingo, who's president of the Mozingo Code Group, LLC. Through her work, which includes being a plans analyst and inspector, Shaunna has provided code adoption assistance and code training to many jurisdictions in the U.S. and beyond. She is a past president of the ICC Colorado chapter and has served on several of the IECC code development and correlation committees. And finally, Shaunna is a recipient of the prestigious Department of Energy's Jeffrey A. Johnson Award for her work in building energy efficiency and codes. Now, this is a webinar about codes, which means sponsored by our good friends at NV Energy. They have this wonderful tool called PowerShift by NV Energy. And that thing helps residential and business owners, or customers, conserve energy and save money on their power bills. PowerShift is a wonderful one-stop resource to find energy-efficient products and services. For more information, you can find out on their website, which is nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for our guest. Simply use the questions box on the right side of your screen. I'm going to review those questions and pose those to Shaunna during the Q&A time that we've set aside after her presentation. Shaunna, welcome back to the program.
Oh, thanks, Mike. So glad to be here with everybody today. Just going to talk, like you said, about this IECC residential provisions. We're not going to go into the whole code and everything about it. I love including building science. I love to include so many things, but we have a short time, and so really going to focus on paths of compliance and some significant changes and some details to pay attention to, as noted here on my next slide. So we really will take a deeper dive into paths of compliance, because I think people are misunderstanding some things there. Doing a bunch of residential studies over the years in different states, different places, noticed some things that people are confusing in the code, or maybe just not quite understanding. So we're going to look at those things to pay attention to, and then of course look at anything that's changed significantly in the 2021 from previous editions. So we will have a question and answer period at the end, but we also are thinking about sometime in the near future of having a follow-up webinar where it's just me and you, and we're just going to sit and talk and have questions. And so there will be at the end my email address, so you can submit any of your code questions for the IECC, and we'll just sit down and have a chat on how to attack your questions. So let's get started, because this is a lot of info. Pathways of compliance in the 2024 are still relatively the same. You have your prescriptive R value or U factor method. You have a prescriptive total UA alternative. People associate that with res check, but it can be other things. So we'll look at that a little bit more in depth. Total building performance and energy rating index. Those are your main paths of compliance. You also can do above code compliance options. You can do, you might have a low energy use building that you could comply with. I think the key to remember is that you pick one path through the code and don't require multiple paths. There are a lot of times that I see people saying, oh, well, I went simulated performance or total building performance. It changes each code cycle between simulated and total. And so they say, oh, I went performance, but the jurisdiction required a res check anyway. Okay, well, res check is for a specific path, and so requiring both might require the designer to jump through some extra hoops. And so we just want to make sure that we're requiring one pathway through the code, and we're following that path from beginning to end. So let's look at those paths. There's the R value method. This R value method eventually changes. You have an R value method and then you have a U factor alternative in the 2021. Eventually it switches. In future code editions, we're going to pay more attention to the U factor method, wanting to look at the whole building assembly. And so the U factor method will be your main method, and then you'll have the R value will be an alternative. But so we have this R value method. The R value is minimum, so I can do this R value as a minimum. I can always do better prescriptively without having to jump to a different path, but if I want to do less, I can't do it using this table. I have to go to a different path of compliance. I don't get to count any framing material or any other part of the assembly. I only get to count the value for the insulation. That gets confused. If you want to count, the R value in the wood and the drywall and the sheathing and everything else, there is a path for that. It's just not this one. And so you can, however, add multiple layers of insulation. So if I have 2 layers of R19 bats in my ceiling, I can count that as R38. Right? The general idea is I can add 2 layers as long as there's not a layer of air movement, if there's not air movement between the two. So I couldn't add a layer of insulation on my ceiling and insulation on my roof deck because there's air movement through there. I couldn't add insulation on the interior and the exterior wall if I have an air gap in between there. So there are different ways to add those layers up and have them count. You have to use the settled R value. So if you do like a blown-in product, it's the settled R value that you have to meet. But also pay attention to the fact that because of the footnotes, we'll look at it here in just a minute. It's also the installed R value that matters. So if you do see a really poor install, then you're not getting the full R20 or whatever your requirement is, and so you would have to increase the R value of your insulation if you're going to install it poorly. So it's better to install it correctly. Because of the footnotes, it says the installed value is what counts. So we'll look at that. The first thing I would say is please don't forget to download your errata. Even if you're in the online version of the code, sometimes the errata doesn't just show up automatically. You have to click a little button to get the errata. They print the book and then we start using it and we find out, oh, we forgot something or we made an error. And so you really want to be addressing the true original version or the true intended version of the code. So you can see here anything in red are things that didn't get printed in the first printing of the book. Or if you're online, you'll have to click the errata button to get it. The main thing is that the intent was to provide a cavity only, especially in some of these colder climate zones, to provide a cavity only, a continuous only, and a cavity plus continuous option prescriptively. And so if you don't have the errata, if you're not looking at the errata, then you don't have those options. So don't forget to download. Read the code language that goes with the table. So if you look let me go back here. Every single one of these components has their own code version. You cannot know everything there is to know about this by looking at this table, right? And so when you say I have a slab and I have to do R10 for 4 feet, what does that mean? You have to go to this code section about slabs to figure out when does it count, when doesn't it? And this is where I see the biggest amount of errors in plan review and inspection on slab insulation. Because people are not reading the code section that goes with it to see that the insulation has to start at the top of the slab to go down, or else it doesn't count, right? It has to start at the top of the slab. Also know that these components are split up now. So you have the installation part that's not tradable, that you have to do it that way. And then you have, you have a different part that just says, go to the table to find out what that R value is. When you go to the table, that part is tradable. If I go performance or res check or ERI, I can trade those values. I cannot trade the installation. Right? And so just some different ways that the 21 got laid out. Read the footnotes. They're very important. There's a lot of information in there. You can see, R values are minimum, U factors are maximum. And then this is where it's telling us that if you install insulation in a cavity that's less than the label or the design thickness of the insulation, the installed R value has to be considered. So if I'm saying like, I'm going to put an R19 in a 2x4 cavity, well, I'm going to have to compress that because it won't fit. What is that installed? Or if I'm going to put an R19 in a 2x6, but I'm going to have a lot of voids and gaps in there, what is that installed R value? That's what has to meet the table requirements, right? And so lots of footnotes in there about different things, how to read the table when it calls for a 13+5 or a 20+5 or whatever. It tells you how to read those. Another good one to pay attention to, especially in climate zones that are higher in elevation, is this U factor, this new thing that came in the 2021 about the U factors of windows. A lot of times the lower U factor that you want to get, the more that those windows rely on argon or gas to get to that low U factor. Well, when those windows travel over elevation and get higher in elevation, that gas dissipates, and so you're not really truly getting the true U factor. So they recognize that and say, okay, if you're above 4,000 feet, if you were supposed to have like a 0.30 window, you can have a 0.32 window for those. And then also recognizing for windborne debris regions to have that different U factor. So just, it's important to pay attention to the footnotes. We don't want to forget that prescriptively. The U factor method is great. This, again, don't forget to download the errata. There's not a ton in there, but there is some, especially climate zone 5, that never had to pay attention to solar heat gain coefficient, now has a solar heat gain coefficient requirement, but it didn't get printed in the code. So make sure you're looking at that. Solar heat gain is hugely important when we're calculating mechanical equipment loads and different things to know how much heat is making it inside the building, so we can count that extra heat in the winter to offset some of our heating costs, but also count that heat in the summer so that we know how much our air conditioner is going to have to make up for that heat. So hugely important. So be sure that you're looking at the right edition of the code. This U factor method is the one that says, okay, you can count the U factor for your insulation, but you also count every piece of the assembly, add it all up and stay under the right amount. So if you looked at it, if I'm in climate zone 5, prescriptively, it tells me I need to have an R20+5. Well, if I look here, it says I only have to have a U of 0.045. That does not equal an R20+5. So why, if these two tables are supposed to be equal, how is that so? It is so because you also add in all the layers of the assembly, not just the insulation. And so you just have to add all those layers. And if you build a really good assembly, then you're going to stay under those numbers. So that's kind of the R value method and the U factor method. I would say I hardly ever see anybody use this U factor method because they don't want to sit there and figure out what the sheathing R value is and the, the drywall and the air film and all those things. But there are some easy ways to figure it out in the back of ASHRAE 90.1, which is for commercial buildings. There's Appendix A, and it has a U factor for every kind of assembly you could ever think of. So that's a source. You can log into ResCheck and just put in one assembly to see what that U factor is. You could go to ASHRAE Handbook of Fundamentals. But for the most part, people will, if they want to do that, they will just go to this total UA alternative in the code, because there's a free resource out there that does all that work for you, right? But so you have this table. It's this same U factor table that's in the code prescriptively. That is also what's behind the scenes in those calculations that we're comparing ourselves to for the total UA alternative. So what this is looking at the total U factor. The total U factor for the entire building thermal envelope, the area of the entire thermal envelope. And it says, okay, if you built it this size of a house with this much windows, here's your allowed U factor based on this U factor table. And then you tell it how you want to build it, and you just have to stay under that budget, equal to or under the budget. And so That's how that table works. It's looking at more than just insulation. Yes, you can put in a better insulation to get out of it, but you could also do less wood, right? So I could say, oh yeah, structurally, I have 1 king stud. That's pretty good, but I bet 2 is better, right? Well, if 2 is better, then 6 must be great. Well, what about 15? Like, these are real pictures. You can't make this stuff up, right? And so if I have all these, you think you're doing this great thing structurally. Well, keep in mind that the 2018 IRC, they determined that there was a lot of fudge factor or a lot of safety factor, I guess I should say, a lot of safety factor in that framing in houses. And so they removed a lot of the amount of wood that was required for headers and for different things. And so wood, we had a lot of safety factor built in. They took some of that out. And when you take some of that wood out, you have more room for insulation. And so you get a better performing wall. If you look at it like this, you can see wherever there is wood in a wall, right? Because wood has about 1 R value per inch, whereas insulation is between 3.5 to 7 per inch. So I can definitely see wherever the wood is. If I had put continuous insulation on that, I wouldn't have all this thermal bridging that is happening in my homes, right? And so I can say, well, what if instead of a stud every 16 inches, I put a stud every 24 inches instead? I would have less wood and more insulation. That's one trade that you can make. You can't make it using the R value table. You could use it doing the U factor table, but if I wanted, I could look at my whole house and the area of my whole thermal envelope and what difference that would make in my U factor. And I could think, all right, I probably, by just putting less wood, I would have more insulation, but I could probably drop the R value of my insulation, and I could probably buy cheaper insulation because I'm putting more of it in. Does that make any sense? Like, there's all kinds of ways to trade. Or you can say, I'm willing to do 24 inches on center, which is less wood, and still use the R20 insulation or whatever is required. But now the two of them combined give me a great performing wall. I can put in a different window, or I can put in different insulation in my attic, or I can, there's different ways that you can trade. And so that's what this path is kind of looking at, saying, now if I do continuous insulation, anytime I do continuous insulation in a building, on a building, I guess I should say, you're going to get a better credit than cavity insulation, because now we don't have all that thermal bridging, right? I have this continuous insulation. People say, oh, but continuous insulation is so intensive, it's so expensive. Well, depends on how you install it, right? Like, yeah, if I put continuous insulation and then I have to cover it with another, material for my drainage plane or my weather barrier or whatever this, whatever it's serving, multiple layers, multiple things installed, yes, I could probably get pretty expensive over time. But if I do my install correctly, then maybe this one product is serving multiple purposes. If I seal all the joints and seams, it's now my air barrier. It's also my vapor barrier. It's my drainage plane. It's my weather barrier. It's my insulation. It's serving multiple things. And I've got such a great credit in my trade-offs. What do I mean by trade-offs? Probably I should say trade downs. I look at the total UA, the simulated performance, and the ERI, these paths that allow trades. I could do something less over here as long as I did something more over here. And so I look at it like a checking account. Anything I do above code puts a deposit in my account. Anything I do below code makes a withdrawal from the account. And so as long as I keep that account in the black, it could be zero, it just can't be in the red, right? And that's how the code works. I can put more insulation in, or advanced framing in, or a better window in to get trade out of something somewhere else. For the total UA, it's only looking at the thermal envelope. Anything that can be converted to an R value or a U factor can be traded. This is why slab edge insulation got removed as a trade. You can't trade if you've tried ResCheck recently. You see that you cannot trade slab edge insulation residentially. You can commercially, But you can't residentially because slabs are not looked at as a U factor. Horizontal concrete is looked at as an F factor. Well, the residential provisions don't ever say F factor. It gets brought in 24, so the slab trades can go back in 2024 because we brought that F factor in. But because it's not an F factor, it can't be traded. So anything that can be converted to a U factor or a R value can be traded in the thermal envelope using this pass. And so it's basically, you have two twin houses, same size, same window area. One is looking at, I should say 2021. The 2021 reference design, it's a geometric twin, same size, same everything. One is just using the prescriptive envelope, that U factor table, right? And one is built the way you want to use it, whatever the builder or the designer specifies. And as long as your area weighted U factor for the whole thermal envelope is equal to or less than the budget, you're good, right? And so it does allow you to trade. Some of the things, I used to see slab edge being the most thing that was traded, but you can't do that right now. But I see it like, I don't want to do R60 in the ceiling, that the 21 now requires R60 in your ceiling in like my climate zone 5. I don't want to do R60, and so how can I trade that? Well, I can put in a better window, or I can put better insulation in my walls, or I can do advanced framing. I can do anything better over here to get out of something over here, or to do less over here. Probably not going to get to trade out completely of something, but you could trade down. The most common way to verify that is ResCheck. It's a free software program online that is created for this specific path. And so a lot of people use it. It's drop-down menus. It's pretty easy. Prints out these reports that you can verify. I have this if you ever want. I have a resource here of, hey, if you're reviewing ResCheck, don't forget to look at these things. Gives you a green line that says if you pass or fail and by how much better. You know, the maximum UA, that's that budget. If I built this house strictly out of that U factor table, here's my budget that I could have, and I just have to stay equal to or less than that. If I stay equal to or less, I'm going to get a green line. You'd be surprised how many jurisdictions that I go to when I'm traveling and doing research that accept them with a red line. They just say, turn in a ResCheck, they turn it in. It has to be done to the right code edition that you're on, has to be done to the right climate zone that you're on, it has to have the right budget, you know, and so it is important that you get a green line. But there are different things to make sure that you're looking at, you know, that these things that they say they're using for construction are truly what the plan shows. If they say they're doing continuous insulation, that the plans show that, right? A lot of times they say, oh, well, I have this R2 insulation. What is that? What are you using that's giving you a continuous R2, right? And they'll say, oh, well, there's some R value in or U factor in that drywall or my sheathing or my air film. No, that's all already considered behind the scenes in the program. You just get to put the physical insulation that you're installing. And so it's just going through and making sure that they're taking credit for what they're supposed to and not getting more credit than they're allowed. So it's pretty easy. If you ever want to do a ResCheck webinar specifically just for ResCheck. But also ResCheck is just from PNNL. It's a, you know, PNNL created ResCheck as an easy tool to show compliance, but there are other software programs. The software programs that do compliance with the performance and the ERI path, Ecotrope and RimRate are the two most popular. They will also evaluate to total UA. You just have to see that it says that they did total UA. So you see, oh, yep, passes total UA based on here's my code budget and I stayed under it. And so, yeah, that's fine. I can do RimRate does it and, you know, and say, okay, here's my code budget and I stayed under it. And so different softwares do it. It's not just ResCheck that can do it. So make sure the code gives you a formula or a way to calculate. It doesn't give you a program name. We're going to get like that proprietary, because anybody that can create a program that does what the code says can turn it in, or you can just, there's people that use a spreadsheet to calculate their total UA, and so that's fine also. So, all right, sorry, all these little clicks. Then you have building performance. So you have, it used to be called simulated performance, then it came total building performance, and in the 2024 it goes back to simulated performance. Right now it's called total building performance in the 2021. It's just a way of trading off or trading down things, but it looks at more than just the thermal envelope. It'll let you trade air leakage, it'll let you trade duct leakage. There's things that also can be traded, how energy moves, conduction, and all kinds of fun things. So it's just, you know, it's the scale. I have to keep my house balanced, and so per the code. And so if you do it, for instance, I could trade off things. I just have to keep everything in balance. I could trade off R values, U factors, air tightness, duct leakage, all of these things, as long as I keep my code balanced in performance. So let's just take, for instance, this ball here is R38 insulation. I'm in climate zone 5. I'm required R60 insulation. So how do I balance out the rest of my building if I want to trade from R60 to R38? And that just means that over here, I'm going to either have to do, you know, better windows, or better, you know, instead of 3 ACH 50, I might have to get 2 ACH 50. I might have to do, instead of 4 CFM of duct leakage, I'm going to do 3 CFM of duct leakage. There's different ways. I could do better insulation somewhere else. There's just different ways that I can do it. I could put all my ducts inside the thermal envelope. There's just different things, but I have to do to keep it balanced. If I'm going to make this trade over here, I have to do better over here. And so that is how that simulated performance works. Instead of a budget UA, it looks at, I have, again, it's simulated, I mean, it's modeled. I have 2 houses, same square footage house in the same climate zone, right? And so I have these 2 houses, one built to the prescriptive requirements of the IECC, and the other one built the way that I want to do it. My reference design is, here's my proposed design. And as long as what I'm proposing costs less in annual energy use than the house built prescriptively, I'm okay, equal to or less. So say I build a house to code and it's going to cost me $1,000 a year to heat it and cool it and water heat it. Then I have to propose a house that will equal to that or less each year. And so it's based on cost. There are some programs out there, Ecotrope and RemRate are your 2 main. There's Energy Gauge, but that's used in Florida. So there's some documentation out there. The code tells you what your document has to say. It tells you what your software program has to be able to do. It doesn't say go use Ecotrope. It says go use a software that does this. Right? And so there's required reports and things that you turn in before CO. And so a lot of the reports are pretty easy. It's just, you have to know what you're looking at. And this is where the confusion comes in a lot of times, is that we're only looking at the heating, cooling, and water heating, which a lot of things go to heating, cooling, and water heating. The whole code is written to reduce the amount of heating, cooling, and water heating. So your air leakage is going to contribute to heating, cooling, water heating, right? There's all kinds of things. But I just say, fill it out, tell it how I'm going to build it, and it says, okay, this is to the 2015. If I'm going to build it, it's going to cost me this much. If my proposed design, the way I've designed it, is going to cost me this much, I'm good. I have met the requirements of the code for that year. You just make sure that it's to the right year, to the right location, whatever it is, 1, 2, 3, 4 place to live. Yeah. So you make sure that it's at the right location, that's the right climate zone, the right code year. A lot of times I see them done to the incorrect code year. That's probably the most. But I also see some that don't pass, right? And so I have, like, this one gets turned in. There's bright red things that say it doesn't pass, but there's also some people that can override the system. So I just want to show you. it'll tell me, oh, it doesn't pass based on simulated performance, but it might pass on total UA, or it might pass a different path, but it's not passing in this path. Why? Because if I built it to code, it'd be $2,200 a year, but the way I've designed it is going to be $2,300 a year. So it doesn't pass. So there's ways to just look at it. These reports also will let me know. I like the reports because they will also let me know a lot of key things. Here's what I'm proposing my whole house mechanical, my ventilation rates are going to be, right? I'm proposing 2.64 ACH 50. A lot of people say, man, they're saying they're doing way less insulation and way less on their windows. How are they still passing? Because they're doing better than code on their ACH 50. Maybe they're doing better than code on their duct leakage. They're putting all their ducts inside the envelope. They're doing things. And so here's how you can see that. You have to read the whole report to see that. And so here's my ventilation rate. So you just can see that. The other thing is a simulated or ERI, Energy Rating Index path. This is, I don't see it used a ton. I think we will start seeing it used more and more. Jurisdictions that are going with trying to get to net zero, and they have some good goals, energy efficient goals, carbon neutral goals, they are the ones using this path a lot more because I can, a score of 100 is a 2006 code house. So if somebody comes and says, hey, I have my house is an 85. I got a score of 85. Well, that just means you're 15% better than a 2006, right? And so that's the 2006. A score of 0 is 0 net energy. Doesn't mean it's 0 energy. It's just 0 net. I'm producing as much as I'm using, but I'm still probably using, and so there's a score system. And so with this path, it's the exact same software, same verifiers, same almost everything that the simulated performance path used. You have that geometric twins. This is comparing you to that 2006, but you're going to have backstops in there, and you're going to have to build this house. You have to do the mandatory provisions, and you have to do a good envelope because you are allowed to put solar on there to lower your score. So it doesn't want, if the solar goes away, it doesn't want to leave you with a bad envelope. So you have some backstops in there, but it just says you have to get a score that's equal to the code or better, right? So if I built this house to the prescriptive requirements, I would have a score, and here's my score that I'm allowed to get, and it changes every code cycle. So here's the score. If I'm in climate zone 5, I have to score 55. Only 5%. This is in the 2021. This also changes how much solar you can use for credit in this path. Changes every code cycle. In the 21, 5% of your total energy use can come from on-site renewables. So that's it. I guess I shouldn't say solar. It's renewables. So 5% of your on-site renewables can come from solar. So I can get a 55, and only 5% of that can come from solar. So this is an interesting path. You pretty much have to build a code house or better to get these low scores. Is really attention to detail. But why do people do it? Well, because some people automatically put in PV. I'm in a subdivision that requires PV. We agreed to that with the development. And so I'm going to get credit for that PV if I use this path. It's the only path that I can get credit for that for. So I'll try that. Or there are other things. I can get credit for a high efficient furnace. This is the only path that lets me have a high efficient furnace or water heater or any kind of equipment like that. I can get credit for that. Puts a deposit into my account that will lower my score, right? I do 100% high efficient lighting. Well, in the 2021, you have to do 100% high efficient lighting anyway, so it doesn't really matter. But I can do a better blower door. I can put all my ducts inside the envelope. Any of these things can lower my score. And so I have a little bit more trade in here than I do in any other path that the code requires. More and more people will start using this path as they try to get to zero because it's an easy, you got a score of 50. Oh, you got a score of 25. Oh, you have a score of 0, right? And so it's an easy way to look at it to verify that. So, all right, those are the paths of compliance. No matter which path you choose, you're going to have to do some additional energy efficiency. So this is new to 2021. It's been in the commercial code for a long time, but it's made its way into the 2021 saying, okay, if you went prescriptive, you do everything that the prescriptive path tells you, but you also have to go into 408 and pick one of these things. You either have to do a 5% better total UA, so a res check that passes by at least 5%, a more efficient heating, basically equals 5%, more efficient heating and cooling equipment, more efficient water heating than you were going to. You could have a better duct system with the thermal envelope. You'd have to read the code sections that go with each one of these. Or you can do a nice tight house with an ERV or an HRV. If you're in climate zone 7 or 8 that requires an ERV or an HRV, you wouldn't get to also take the credit for that in this. So you have to pay attention to how those work. But if I go prescriptive, R value method, U factor method, total UA, those are all prescriptive paths, then I have to pick one of these on top of the requirements. Pick one. If I go simulated performance, I have my option of picking one of these or getting my proposed design has to be 5% better than the standard reference design in the code, right? I have to do 5% better overall. If I do an ERI, that score of 55 now has to be 5% better. So no matter what, when I'm looking at this table in the code, I'm going to automatically assume that I have to do 5% better than this because it's the only path that I get in this additional energy efficiency. I have to do 5% better than that score. People always say, well, then why didn't they just make that score 5% better if you have to do 5% better? I guess because people could amend this out or could change this or whatever, and they want you to have that base score. So just know you got to do 5% better. But this is the difference between this and commercial is that commercial, it only complies prescriptively, but in residential, it applies to any path you choose. So make sure that you're paying attention to that. All right, now I'm going to jump into some things that I've seen people be really confused over. And that's usually in the thermal envelope. Right? It's some specific things that I see people getting messed up on. One of those is floor insulation. Floor insulation, you know, it's always said floor insulation has to maintain permanent contact with its subfloor, but then Joe Stebrick and the home builders and Robbie Schwartz, they all have worked together over cycles to bring in this amendment or this exception to allow the insulation to drop down. You just have to be, it's very specific. I want to drop my insulation down because then I can run all my ducts in here and have them be in conditioned space. Oh, that's going to lower my ERI score. That's going to make it better for my performance, right? I'm going to get a credit for that. Well, that's fine, but it's very specific on how you have to do it. So you just have to make sure if you're going to lower that down, the insulation to the bottom of the assembly, instead of in permanent contact with its subfloor. It's just very specific in how you do that. You have to have a layer of continuous insulation on the bottom. It doesn't, a lot of pictures I see are like, oh, here's rigid foam board. It doesn't have to say that. It has to have a layer of continuous. That could be thermoply, has some R value to it, right? Across the bottom and your drywall. So I have my air barrier. And I have insulation. Between this insulation and this insulation, it equals my floor insulation. If I do that and I seal up the cavity so air isn't moving, I can have air in the cavity, I just can't have it moving because then I'm losing efficiency, right? And so as long as I do that, I build a good sealed up plenum basically, then I can run my ducts in there and have them be inside conditioned space. But just make sure that you're following the letter of the exception, and that is exception has changed every single code cycle since it got brought in. They keep trying to, you know, make it better, make it more easily understood. Another place that I see a lot of problem with is slabs. Slab, slab, slab. You know, these pictures come right out of ResCheck. They're trying to let you know also that, hey, if you do it this way, this is boilerplate what I see on the plans most of the time for commercial or residential. That's fine if you want to do insulation below the slab. You can't count it as part of your thermal envelope insulation. Remember I said that each one of those components has a code section, and it says in that code section that insulation has to start from the top of the slab down. There's where your thermal envelope is. This is doing nothing to protect that. It has to start at the top of the slab. So it can be on the outside or the inside. You can go down and under on the inside. You could go down and out on the outside, and it gives you very much specifics on what you have to do each time in the code section, right? And so this is I see this so common, or I'll go out on inspections and I'll look down and I see the slab edge insulation on the inside, but there's 4 inches. Why is there 4 inches? Because the slab is 4 inches, right? And they're going to get ready to pour the slab and it's going to look like this. That's fine if you want to do that. Just spend your money on the insulation. I'm sure it serves some purpose somewhere, but it doesn't serve the purpose that this code section is after in protecting the edge of that slab. Again, you're not allowed to trade it off in residential anymore until the 2024 gets here. But if you're a jurisdiction that is confused about slab edge insulation or is trying to amend this section and you want to know how to get it to work in ResCheck, please just send me an email. Lots of workarounds, okay? Making sure you have the details correctly is important. The code requires details, insulation and air sealing details beyond the plans. And so you really want to make sure that those details are correct. There's tons of ways to do it. Do make sure that the structural engineer is okay with whatever you end up doing. I have run into cases in the last year where the architect will design a slab edge insulation and the engineer will say, no way. I'm not going to have half my wall sitting on insulation or hanging over or whatever it is. So just make sure that everybody's okay with what you decide. Air sealing is hugely important. I'm not going to go through this entire table. I love to usually show you picture after picture of what to do and what not to do. Just know we're trying to get to 3 air changes per hour or 5 air changes per hour, wherever you're at, depends on what that number is. And the only way to do that is to air seal. This is your roadmap to passing your blower door, so you need to pay attention to it. A couple places that I find it getting wrong. We're trying to build a tight house. Well, yes, we have to bring in air, but we're trying to have more predictability and more resiliency, right? We want our homes to last. Wherever air can get in, moisture can get in. We want to build this tight house. That way, I don't have new air coming in all the time, bringing in with it whatever it's bringing in, and I'm reheating and recooling that air all of the time, right? And so we're going to bring in air, but at a controlled amount, and I'll know where it's coming from and what it's bringing with it. So we have this requirement in the code, you know, in climate zones 1 and 2, 5 air changes per hour at 50 pascals. In climate zone 3 through 8, 3 air changes per hour. I want you to pay attention. People keep telling me, no, the code doesn't say that anymore. The 2021 doesn't say that anymore. Yeah, it really does. It's that you have to read it. They printed it in out of order. You know how when we write a code, we say, here's the requirement and here are the exceptions. For some reason, when this got written, the exception is first and then the requirements. You have to read all the way through 401 and 402 to get through it. So 40121 says, hey, if you go prescriptive, you have to comply with everything in 401 through 404. All right, great. Well, 402 is in there. So I go over here and it says, hey, the building or dwelling unit has to be tested and it can't exceed 5 air changes per hour. Everybody's like, oh, the code rolled back. It's 5 air changes per hour in all climate zones. That is not what that's saying. So I'm just going to trying to walk you through this because then if you keep reading all the code sections in 402.413, the very next section says, here's the leakage rate. when complying with 40121, which is prescriptive, then it's 5 air changes per hour in 1 and 2, 0, 1 and 2, and 3 air changes in 3 and 8. So if you're going prescriptive, there's the 3 air changes per hour and the 5 air changes. If you're using a different path, you're going performance or ERI, you still have this 3 and 5 limit, but you can trade up to, it shall not exceed 5 air changes per hour. So I can, if I do better than 3, I can use that as a deposit in my account. If I do worse than 3, if my requirement is 3 air changes per hour and I do worse than 3, I can do worse all the way up to 5, but I have to use that as a withdrawal from my account. I'm trading it, right? And so that's what that's saying. It's just that they put this section first, and so people automatically just see it, oh, 5 air changes per hour, I don't have to get 3 anymore, and that's not true. So just how to read that section of the code. You're trying to get, less leakage. You're not saying we're going to get 0 leakage, just trying to get less leakage so that we don't have to offset that heating and cooling so much. Couple little places in there, make sure air permeable insulation isn't used to seal things up. It works for draft stopping or fire blocking, but it does not work for energy efficiency. There's a big myth out there that insulation stops the movement of air, and that's some does, but not permeable. So, right, it resists conduction, but it doesn't resist airflow. It needs an air barrier. So making sure that whole table is about where's my air barrier and what's my insulation, and are they, in alignment with each other. And so making sure that you're doing that. Insulation traps pockets of air. In the wintertime, I'm from Colorado. In the wintertime, I wear a fleece jacket all the time. It keeps me warm until the wind blows, right? Once the wind blows, then I can feel that air moving through my insulation, and I need an air barrier. I can wear even just a light windbreaker over the top of this will keep me warm and trap those pockets of air and make it work, right? And so that's how insulation is. If I have a permeable insulation, it has to have an air barrier in order to work. The one place that I'm seeing in every state that I've looked at and done a residential study of late is this disconnect in dropped ceilings. So I have a ceiling that needs to be insulated, and I have this conditioned space, but I have dropped chases, dropped ceilings, and I'm not insulating, or I'm not getting my air barrier continuous. So my attic air is getting in to my walls and to my space because not continuous with that. So pay attention to those locations. I'm seeing that missed a lot. The seal plates, there's, yes, definitely, I put this on here. I'm not going to go through everything, just highlights. Just know the walls say the thermal envelope insulation for walls has to be installed in contact and alignment with its air barrier. So I can put insulation in the wall and call the Tyvek on the outside of the wall my air barrier, right? Because my insulation isn't in contact with it. I could call the sheathing my air barrier as long as all the joints and seams of this sheathing are sealed, but not very many people seal up all the joints and seams of sheathing unless you're using like a zip system or something. So you have to be careful. It's a lot of times the drywall on the inside of the wall, which means I have to fill the cavity because my insulation has to be in contact with its air barrier. Just paying attention to that. Yes, there are some insulations that have their own air barrier, and so that's okay. But just know that that's an important part of that gets missed. Another place I see get missed is behind tubs and showers on exterior walls. These tubs come in early on in construction because there's the doors aren't on and they're big and I need to get it in. Next thing you know, they're set in place and they don't have any air sealing behind them. And so you get some insulation, but you don't get air sealing. Where's my air barrier? But I usually walk the job site in the beginning, like, oh, there's going to be a tub there. Get a sheet of thermoply or something and put it on there and seal it. Then you can come and insulate behind it later, but get that air barrier in there. It's really hard to go back and do after the fact. And then seal between the house and the garage. The code says you have to air seal between the house and the garage no matter what, because we don't want garage air coming in. So we want to make sure that we're really sealing between the house and the garage. That has to be there. Where I see the disconnect is all the way up. If my attic and my garage share, okay, but then if I'm not getting my lids really tight, then anything in the garage is coming into the house. So just making sure you have true thermal isolation, but true air isolation between the house and the garage. And then provide ventilation. This is where the 2021 brings in some changes also, not necessarily in your ventilation rate. You have the IRC that tells you how much ventilation you have to get. There's a table or a formula. If you did the table, or if you did the formula, you'd come up with, in this instance, if I did the 1,500 square foot house, I'd only need 52 CFM, but because this is worst case scenario for the 3,000 square foot, I'd have 75. Some people want to do the minimum, some people want to do the maximum, but you're allowed to do either or. Here's the change, is that you have to test it. The system has to be tested to make sure you're getting the codified amount at a minimum or a maximum, that you're getting the right codified amount of airflow with whatever you're using. So that is new to 2021. Also new in 2021 is the removal of an exception that used to allow you to not have to test ducts within the thermal envelope. Now all ducts have to be tested. The difference is the testing rate. 4% leakage was what was in that 2018, but I didn't have to test in the envelope, in ducts inside the envelope. Now it says 4% total duct leakage for those that are outside the envelope and 8% duct leakage inside the envelope. Still have to test, but they can have a little bit more leakage. Here's where I find the biggest problems. We're almost done. Here's where I find the biggest problems is sealing at the air handler. I'm seeing ducts being sealed all day long. It's lots of pookie, lots of tape, got your mastic out there. I've seen the ducts sealed. Where I'm finding is at the air handler. The duct's connection to the air handler is where I'm seeing the most amount of leakage. Where those filters are, there's just places at the air handler that are not being sealed. Now, this is just a quick video, if I can get it to work, showing maybe this is my connection at the air handler. This is in Las Vegas. You can see, obviously, but you can see the air leakage of a poorly sealed curb. It's those places. It's not the duct. We spend so much time going around trying to find the ducts, and it's not. It's at the air handlers. That's what I'm seeing right now. So the last thing is lighting. New changes for lighting in the 2021. 100% of the lights have to be high efficacy. We started at 50, then 75, then 90. Now we're at 100% of the lights are high efficacy, except for those applying, like the light in your refrigerator doesn't have to be a high efficacy label. You now have lighting controls in residential that you never had before. You either have dimmers, occupancy sensors, or some other way that's built into this fixture to shut the lights off, except for in certain places. The 2024 changes this even again, but to require dimmers in the house and occupancy sensors in all of these places. So something to keep in mind there. Where you're going to see, where I'm finding the biggest cost is coming in on the exterior lighting controls. So if you have more than 30 watts outside, you have to have lighting controls. Control a manual on-off switch, controlled by a manual on-off switch that has auto shut-off, but you can't use that for multifamily. So that's for houses. You can have a manual, which means everything has to be automatically shut off when there's daylight present, or controls that override the auto shut-off actions are not allowed unless it automatically returns back to normal operation. So I have to automatically shut off the lights when there's daylight present. So I have to have those photo sensors basically. I have these photo sensors, and there's some exceptions, of course, right? And so if I have, I think the wording is like, if each unit can be controlled on its own, you could have this on-off switch. But if not, and you have multi units covered under some of the same lights, then you have to have the daylight, the photo sensors. And so you're going to see some costs now going into the lighting requirements, lighting control requirements in the residential. It changes again in 2024. So just be aware. Phew, that's not everything in the code. That's near what I, want you to know about the code. That's just a touch that we do so that I could leave some time for some questions. So, Mike, do we have some questions that have come in?
Oh, you better believe we do, Shaunna.
Okay.
And I just put something in the chat asking people if they do have questions. We're going to take the ones that we have gotten in so far. So the first one came in from Ruth, who wanted to know, is the installation guidance new with this version of the IECC?
The installation guidance. Oh, no, actually it's been in there for a long time, and that's why it's a footnote. You have installation guidance. Well, I guess it depends on what part you're talking about. Let me just take that back. I've always had chapter 3 that says install guidance. If you're going to do more than one layer, you're going to have to offset the layers, da, da, da. You've had that footnote in the code for a long time that said that the install value is what counts. What changed in 2021? Sorry, I'm so many versions of the code. What changed in 2021 was that split out of each of those code sections for the component that say, here's what's mandatory for install, and then here's the trade-off amount that's in the table, right? Like it split out the install versus, hey, install for the table. And so that's the only real change, but no, it's always been the installed value.
Okay. Franziska wanted to know, where you have a 2x4 or a 2x6 wall, do you adjust the R value because of the reduced R value of the framing versus the insulation?
It depends. So let's answer. If I'm doing the R value table, I just go with whatever it says. So if it's, remember that my cavity will have to be filled. So if it says I have a requirement for R13, that's assuming a 2x4 wall, because an R13 will not fill a cavity of an 2x6 wall, right? If it says I have an R19 or an R20, it's assuming a 2x6 wall, because that's going to be too much in a 2x4 wall. So the R value method, you just use whatever R value is in the table. If you're doing the U factor credit, that's when you give yourself credit for what size that stud is, how far spaced they are, what's the value of the insulation. So one is the assembly. U factor is assembly. It's even for a window. You cannot get the true U factor of a piece of window by just center of glass U factor. You have to, okay, you have this glass. What kind of frame is it going to be in? And is there any insulation in it? And so it's the whole assembly. That's when you can give yourself credit. So if you go R value method, only credit for insulation. Any other method, you can get credit for the wood also.
Okay. And Joseph wanted to know, can you give us the definition as it's defined in the code of a lighting control?
Well, probably you're not going to find as good of a definition in there as we want. Let me see if I can pull up I got to get it on the right screen so that I can show you. I don't think you're going to get a lighting control definition in the 2021 for residential. But we'll just look and see real quick. It's asking you, it's pretty much asking you for, I don't think it's going to give you one. We'll look, but I don't think it's going to give you one because it's saying, here's what the control has to do, right? In the code section, when you're in the IECC, I should just go to the online version instead of this one because it doesn't have errata in it. But if you're in 405 for lighting, it'll tell you, that you have to do these certain controls, and it gives you definitions for lighting or for all kinds of things, but it tells you here's what the control has to do. If I go to my definitions section, I have a hard time believing I'm going to have a definition for a lighting control. Occupancy sensor is in there, and I think even dimmer is in there, but that's about it. I think you could probably go to your commercial section where lighting controls have been in there forever to figure out what a photo sensor is and all of those other things. But basically, it's just telling you, it has to do what this code tells you it has to do. Right? So it's a very confusing section. I've had some huge long discussions on this exterior lighting controls and the penalty that it's going to have for multifamily buildings.
Okay. So here's an interesting question. I don't know if you've run into this one, Shaunna, and I know you've run into many a question throughout your career, where the automatic shutoff for outside lighting has to be restored within 24 hours. What instance motivates such disabling? Is it something like an eclipse or a snowstorm, or what is that?
Why would you disable it?
Yeah.
So you have this lighting and it has to turn on, and then there's some kind of thing that overrides it. Maybe you override it because you're going on vacation, or there's some reason that you want to override it. Maybe there could be because almost all lighting has override, but there could be something that shuts out the power. It has to have the ability to reset. All the commercial lighting says the same thing. It has to have the ability for that, for it to reset if you lose power for some reason, whether you shut it off, or maybe you shut off the power because you're doing some construction, or there's a weather event that shuts off the power. When it comes back on, the lighting controls have to reset.
Okay. All right. Well, I want to make sure to share some breaking news with our audience, which we don't normally do at the end of one of our webinars, but that is that we've taken some questions now, but what we would like you to do, audience members, is to think about what other questions you may have, look through the code. There is a free read-only version online. Is that not correct, Shaunna?
True, truly. Mm-hmm.
And come back to us in 2 weeks, because we are going to hold an interactive discussion with Shaunna on codes. So you're going to get a chance to ask in-depth questions on all things code with her, and that is going to be the whole sole purpose of that discussion. So look for more information on that in a post-webinar email from Green Builder Media. So this is a brand new announcement. You haven't seen anything about this yet. This is something that's been worked on in the background, but it's also why you see on her, email me your questions for our next webinar. It's going to be actually a discussion. So instead of a formal presentation like this, it will be a discussion with Shaunna. You'll get a chance to ask her questions. It's something that is really, really cool. I think it's a great opportunity for those code geeks out there like us that look through these things. So I want to stop right there, if it's okay, Shaunna. I want to thank you very much for sharing all this information with us. And you're right, there is a ton of information, ton of changes in the code, all sorts of nuance that happens in there. It's not easily digestible in 45 minutes, right? But my hope is that you, the audience member, are able to kind of think a little bit about some of the things that she's talked about today, look back at either the code you're using or, like I said, the read-only free IECC. It's out there that you can check, and come back to us in 2 weeks and bring your questions, because that's what we're looking for. I want to thank the questions that came in today. Thank you so much, audience members. Thank you to Power Shift by NV Energy for their wonderful sponsorship of all things codes here. It's really wonderful, their dedication to providing outlets for people to get code information. So when it comes to webinars, okay, because that's going to be a discussion, different kind of format. But when it comes to webinars, our next event is actually going to be part 1 of our Housing 2.0 workshop series with Sam Rashkin. That's right, the Series 2 workshops start on Thursday, October 17th. So that'll be just the day after Shaunna holds her discussion on codes on October 16th. So October 17th, workshop series starts up again. They're going to run on 4 consecutive Thursdays. They're going to start at 12 p.m. Eastern time like we normally do. For more information on that, you can go to greenbuildermedia.com/housing-2.0. Until next time, I hope you get a chance to get out there and enjoy the fall colors that have already probably started arriving in the northern part of the U.S. And keep in mind those who may be affected by the hurricane that is imminently arriving on the southern side of our country. Until next time, stay safe, stay healthy, and take care, everyone. So long.